Okay, let's take a look at a similar problem, but actually very different in the sense that this is a cube root here, and we are actually dealing with a slightly different situation because of the position of this negative number here. So notice it's a cube root, but our equation still applies. If you notice that the vertex form of these is virtually the same. Our vertex form was a cube root of x minus h, all under the radical, okay, plus k. All right, so even though this is a cube root, and the last problem we did was a square root, this formula still applies. K is going to shift it up or down, okay, based on what that number is, and we see we have a minus 7 here. H is going to shift it left or right. When I say it, I mean the beginning of the graph. And A is going to make the graph, okay, broader if it is if A is greater than 1. It'll make it skinnier if it's less than 1. If the regular graph look like this. Now notice it's a cube root, so I've already kind of made a mistake here where cube roots don't just stop at the origin, they go like this, right? That's my regular y equals cube root of x. Okay, this first dotted graph in here. If a was greater than 1, that would make the graph wider. If a was less than 1, if it was a fraction or a decimal, it would make it skinnier like this, closer to the x-axis. I hope that makes sense, even if my drawing here is not perfect. Okay, so let's go back to this now. Let's take a look here and let's work some problems here. This is my k. It's looking for a positive, so k is minus 7. Okay, that is going to shift the graph down 7 units along the y-axis. And so if I know what cube root of x looks like by itself, I just redraw it 7 units down. Okay, so if cube root of x, and cube root of x normally looks like this, right? We graphed it in class that one day, I think, something like this. Okay, I look for perfect cubes here. So let me just help myself out a little bit here by picking some easy numbers here. It's cube root minus 7. So we're going to try that. Cube root minus 7. That's my function. Let's pick some x's and y's that are easy, and we will graph this by plotting points, but understanding that it's going to look something like this shape here, but shifted down 7 units. Okay. So first of all, why not do x equals 0? That's going to be my y-intercept. Cube root of 0 is 0 minus 7. So 0 minus 7 is minus 7. 0 minus 7. All right, there's 6, there's 7 right there. So there's my beginning, or that's where the graph's going to cross. Okay, let's try a 1. That's easy. Cube root of 1 is 1. 1 minus 7 is minus 6. So when x is 1, okay, this would be minus 6, and that's going to be right there. Okay, let's try a negative 1. It's a cube root, so we can have negatives. I strongly recommend you go through all the perfect cubes because it's easy to do the math. Okay, cube root of negative 1 is negative 1, right? Negative 1 times negative 1 times negative 1 is negative 1. Therefore, the cube root of negative 1 is negative 1. I hope that wasn't too much for you. But negative 1 minus 7 is a minus 8. So at negative 1 right here, we'll have a minus 8. Oh, that makes sense. It's going right like this, right through our graph, and it should taper off like this if you look at the shape of my pen. So let's keep going with perfect cubes. What's the next perfect cube? 1 cubed was 1, 2 cubed is 8, so let's try x equals 8. Why? Because I know what that is. Cube root of 8 is 2, 2 minus 7 is minus 5. So at 8, it's going to be minus 5. There's 8, there's minus 5. There you go. Oh, look, it's going to do exactly what we said it was going to do. It's going to go out like this. Okay, let's try one more. Okay, let's say minus 8, because I know that's the perfect cube, right? Cube root of minus 8 is minus 2. Minus 2 minus 7 is minus 9. So at minus 2, it's going to be minus 9, which is right there. Oops, sorry about that. Minus 2 is my x. Minus 9 would be right there. And clearly we see this trend right here, okay? We have exactly what we were talking about in our vertex form. Oops, my graph's not perfect. It shouldn't be this flat here. Probably a little bit more like this, okay? A little bit more like that. It's hard to write on this device here. But there's our graph, okay? And notice this is simply the graph of y equals cube root of x, but it's shifted down 7 units. 1, 2, 3, 4, 5, 6, 7 because of this minus 7 here, this k value. Okay, so once you get familiar with what y equals cube root of x looks like, same as our square root functions, we hope that you can see that shift. We hope that your knowledge of the vertex form here helps you understand what that graph will look like. The other thing though is plotting points doesn't hurt. Looking at a known value of the graph, if you have a graphing calculator or this software here, okay, this would be what this one looks like. I believe you're going to have x to the 1/3 power, and then I'll just do a -7. There's my cube root of x. Notice the graph over here. Now I'll just do a -7 outside of it, and it just shifted the whole thing down exactly like we just showed. Okay, so there's your graph of x to the 1/3 or cube root of x -7. It looks very much like the graph we just developed quickly with plotting these points.